we talked about relative max and relative min. So in this example, this is a relative min, this is a relative max. But we never talked about absolute max and min. What does this mean? So here's an example. I'm going to do this, sorry. I'll explain why. So here's a function. And in this function, as you notice, this is on a closed interval. What does that mean? Well, it starts at this point and it ends at this point. This goes on forever, as I graphed it. But this one is on a closed interval between this value and this value. That's it. I'm going to say between -10 and 4 as an example. Now notice the following. No secret, we've done this before. This is a relative max. No secret, we've done this before. This is a relative min. However, this point here is also absolute minimum, because there is no other value smaller than it in this function. This is it. This is the bottom of the bottom. It's a relative minimum because the function exists on both sides, and that is the minimum point. It's an absolute minimum because this function does not go anywhere else lower than this value, whatever the value is. This is a relative max, but it's not an absolute max because there are values higher than it. This, however, is the absolute max for this function. There is no other value higher than it. This is never local or relative, never, ever, ever, because the function does not exist on both sides of it. Oh, I'm so sorry. Oh, I'm so sorry. Let me do this again. You couldn't see, right? I'm sorry. So we're talking about absolute max and absolute min. And I graphed this function. This is a relative max. This is a relative min that we know. But this is also an absolute min because the function has no other values below this value. This is it. This is the smallest. This is a relative max. This is the absolute. Why is it the absolute? Because there is no other value higher than it. But it's never a local. At the end points of the interval, we can never have a local because the function does not exist on one side. And what is this one? Nothing. Because at the end point, it can only be absolute, never relative or local. It's not absolute because they're minimum, because their values smaller. It's not absolute maximum because they're higher values. And it can never be local. So this point does not represent anything. Relative max, relative min, but also absolute min, and absolute max, but never local. So I want us to look at a graph in the book. Please stop me if you have questions, please, please. I would like us to choose a graph and discuss it here. Any graph you like. Anyone?
We look at number 5 there.
Okay, so looking at the graph here, notice that this is never a local. Why is this point never a local minimum?
Because it's an endpoint.
Because it's an endpoint and the function does not exist on the left. Is it an absolute minimum?
It is.
Yes, it is, because it's the smallest possible value, and the endpoints of the interval can be absolute. Perfect. What about here? Is this a relative max?
Absolute.
Absolute and relative, because it exists, the function exists on both sides. It's a relative, but it's also absolute because there is no other value higher than it. Good. What about this point here?
That one is neither.
This point is a relative minimum. I'm showing here at 1.7. This is a relative minimum here, but it's not an absolute minimum because there are values smaller than it. And this one here at 1 indeed means nothing. It's not a local because it's at the endpoint. It's not absolute minimum because there are other values smaller than it. And it's not an absolute maximum because there are other values higher than it. Excellent. Good. So now let's choose a function and study the absolute max and absolute min on the given interval. Okay, I'll choose 19. Let's take a look. Which page am I on? I think I'm on 8. Good. F of x equals x plus 4 over x, or negative 8 to negative 1. Good. X. When we study max min, absolute max, absolute min, we only need the first derivative. When we graph, we need both. I only enter negative 8 and to negative 1, nothing else. This is the world for this function. We cannot enter anything else beyond to the left of negative 8 or to the right of negative 1. I have to find f prime. Can anyone calculate f prime for us? Remember, we know how to calculate 1 over x prime. Can anyone give us? We have to find f prime. Anyone, please? Anybody?
Is it just 9?
We're differentiating x plus 4 over x. X prime is 1. When we differentiate 1 over x, we get negative 1 over x squared. Is that okay? Good. So we find the least common denominator, x squared minus 4 over x squared. So we have to set f prime equal to 0 or f prime equal to undefined because we are looking for critical numbers. Critical numbers come from 2 sources, f prime being 0 or f prime being undefined. Can anyone look at this function and say f prime is undefined when x is, and f prime of x is 0 when x is? We had this situation last time. A fraction is 0 only when the numerator is 0. A fraction is undefined only when the denominator is 0.
So for the first part, would it be 2 and -2?
Excellent. Because x squared minus 4 equals 0 means plus or minus 2. Excellent. And the other one?
It'll only be if it's 0.
Perfect. Excellent. Now we only care about -8 to -1. Nothing else. 0 does not belong here. Careful now with positive and -2. Positive 2 does not belong here, but -2 does. I cannot plug in 0. It's not in the interval. I cannot plug in 2. It's not in the interval. I can only plug in -2 because that's what I was given. I was given to study the function, find max, min, absolute max, absolute min on the given interval. Nothing else. Good. So now I plug in this function in the calculator, and I will plug in -8, -2, and -1, and write the y coordinates of these three values. So let's go to y equals. And in y equals, clear x plus 4 divided by x, and plug in -8, -2, -1, -8, -2, -1. So I got -8.5, -4, and -5 respectively. Good. Now, at this point, I have to study the sign of the first derivative. So here's the first derivative. The denominator is positive. Don't worry about it. Don't even bother with it. If I plug in -8, I have 16 minus 4, which is positive. If I plug in -1, I have 1 minus 4, which is negative. I have to make sure that this row of f prime and the row for f work well together. If they don't, then I say, uh-oh, something is wrong. So from -8.5 to -4, yes, it's increasing, that's correct. From -4 to -5, yes, that's correct. Now I have to make a decision. What is the decision all about? What is this point? What is this point? And what is this point? Let's say I don't understand all this, so I'm going to do this. The height here is -8.5. Then the height here is -4. And then the height here is -5. This is not the graph of the function. I'm just looking at the y values, something like this. This is a depiction of what I see here so I can make a better decision. What will you say about the point -8, -8.5?
The minimum?
Yes? What type?
Absolute.
Absolute. Can it be relative?
Would be no, because the function doesn't continue.
Excellent, excellent, excellent. Yes, because this is at the end point. At the end point, we can never have relative. Excellent. Thank you. What about this point? -2, -4.
Absolute and relative maximum.
Absolutely. Absolute and relative or local max. Excellent. Perfect. Finally, this point. -1, -5.
Is that what
It's
just
neither.
Nothing. 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 It can only be an absolute, but it cannot be an absolute because I already have an absolute minimum, I already have an absolute maximum, and this is somewhere in between. I may have two absolute max or absolute min. That's possible. So for example, I may have a function like this. I have two absolute min. The first absolute min is at x equals 1, and the other absolute min is at x equals 5. I can, but not here. Negative 8.5 is the absolute minimum, negative 4 is absolute maximum, and negative 5 is somewhere in between. It's nothing. Good. Okay, we'll stop here. Let me know if you have any questions. I know it's a lot. As I mentioned, I told you chapter 3 is intense. I'll try to make it as simple as possible, as I said. But it is intense because it has a lot packed in it. And this is not the end. Thank you. Please stay if you have any questions.